We're not in the commoditized data capture space. We're not the smart cookie in the room that knows all models for all kinds of crops and all geographies. But we are the tenacious connector and the thinker to bring those together and enable the universities to get their science out of the lab and get to the farmers.
Welcome to the Space Angels Podcast, Episode 13, Farming with Satellites. I'm your host, Chad Anderson, CEO of Space Angels, the world's leading source of capital for early-stage space ventures. You can find us on social media at Space Angels. In this podcast, we explore what is happening at the bleeding edge of entrepreneurial space and speak to the founders behind the companies at the forefront. The Space Angels Podcast is brought to you in part by our friends at Cosma Schema, the new space design and branding agency. With a suite of services like brand positioning, company and product naming, logo design, and web design, they're the only design agency exclusively serving new space companies. We recommend all our portfolio companies to Cosma Schema, and you can view their work at cosmaschema.com. Today's guest is Anastasia Volkova. She's the CEO of Fluorosat, an integrated analytics platform that leverages imagery, ergonomic models, weather, and IoT data to provide conclusive insight to agronomists. We recently invested in Fluorosat, along with M12, the venture arm of Microsoft, and a number of other well-known funds. Anastasia, welcome to the podcast.
Thank you so much for having me, Chad.
Okay, so I'm excited to dig in and talk about Fluorosat, but first I'd like to ask you a few questions about yourself and let our audience get to know you a little bit better.
Sure.
So you are certainly well-traveled. Originally from the Ukraine, you are now based in Australia, but you're also spending a lot of your time in the US. Building your business. So how did you get here running a business in both hemispheres?
Wow. Well, look, when people ask me, where's home for you? Which is a pretty standard American question, I pause for a few seconds because I still don't know the answer. And whether home is Europe, whether home is Sydney, whether home is LA now, where my partner and I live, or whether home is just the world, how did I get to run the business in both hemispheres? Well, I think I was born as a global citizen. I didn't see the boundaries of the countries. And, Europe, being born in Europe really helps with that because you can imagine yourself being in any of those countries at any given point in time for a weekend or for a couple of weeks holiday. And when I came to Australia, although it's a bit, people say it's isolated, it's actually very connected because people from all over the world come to Australia and Australian innovation reaches everywhere. And so we obviously knew that American market would be the biggest target, as well as the early adoption here is really a thing. In many places in the world, it's not, especially if you're talking about farming. And there is an opportunity here to be really pushing for technology.
Great. And so you've previously been involved in projects with NASA, robots on the space station. And now I'm seeing photos of you on social media hanging out with Satya Nadella, CEO of Microsoft, who is now an investor in your company. So a little bit about your career and your background and what inspired you to go from being an aeronautical engineer to an agricultural entrepreneur.
Yeah, that isn't a straightforward transition, hey?
Yeah.
I often reflect on that Mom would have never told anyone that I was going to be first an aerospace engineer and then go back to ag. It's an interesting story. So I was born in Ukraine, then I did my studies in Europe and Poland and partly in France. And my PhD out of Sydney University also connected me to different labs around the world. And what I realized during my degrees is that remote sensing, which is basically a part of Earth observation, it's covering things like satellites that are looking down at Earth and are constantly imaging it. Many people have heard about, Planet Labs or different types of space companies that are launching what's called shoebox satellites that are looking down on us and are registering everything, at least every, square meter once a day. That's phenomenal. And that's why I was fascinated with Earth observation. And, for someone like me, I really wanted to make a sustainable impact. And what I mean by that is that I want to look into the eyes of my kids and say that your mom is an aerospace engineer. She has actually done something great for the world going forward to make it more sustainable so that you can live in, and your kids can live in, and your kids can live in. Whilst aerospace is, when you think of it, people often call us rocket scientists, and they think we're only dreaming about going to Mars. And I understand that fluorescence might at some point have a module for potatoes on Mars. Like that's totally within the vision. But at the same time, it's actually what's happening down here that's important to fix first. And so that was my vision. And doing a PhD with basically a NASA camera system bought by Australian Defence and Science and Technology Organization gave me the edge of understanding how the sensors and what was coming down from the ground was connected. How could you see where the cars were, where the trees were, where the grass was? Was this grass better than that grass? Is this wheat? Is this cotton? Is this almonds? And then you start piecing it together. And then I went to the market and asked whether that was actually available to them. And they said no. And I said, well, that's not how it should be. That information is out there. You're making decisions based on it every day. It has to be available. And this is how Fluorosat was born.
Interesting. Okay. And then, so I see a lot of PhD entrepreneurs, academic entrepreneurs, have a very interesting theory or have a very interesting piece of IP or technology, and they struggle to commercialize it. And I've seen this countless times and don't know exactly. I think it's probably a number of things that's the cause of this. But I'm curious how you've found success, and quite a lot of early success as an entrepreneur, where so many other PhDs and academics have struggled.
I would say it actually depends on the person. And even we are hiring PhDs. I'm trying to dig into why they started their PhD. Because in some cases, like in Australia, you actually want to come to Australia and you're looking for a longer term cause to do it. And that's why some people choose a PhD. So it's a very unique case. Whilst if someone is from Australia and they're doing their PhD there, they have a very different motivation to do it. So that's basically telling you something about the person, whether they're academically minded or they're industry minded or commercially minded, right? And so for me, people often forget that part of the story, but we had two businesses with my technical co-founder before Fluorosat, and I was always driven by what actually moves and shakes the market, not just by academia and, what's the edge of the innovation that you can get to. To me, it was important that it was applied. And I look at the innovation in academia from that perspective, from the perspective of, is there an end user? Am I doing this for someone who will use this tomorrow? And I think people say that, millennials are really hooked on impact and they really want to see that they're becoming a part of something bigger. And I think more and more PhDs should open up their minds to that. Mm-hmm. And there are a lot of commercialization programs now. But I think that one of the secret ingredients there is actually, what's your purpose? Are you doing it because you just want to be advancing your own knowledge? Are you doing it because you want to be advancing humanity's knowledge? Or are you doing it because there's a problem you want to fix? In the last case, you maybe can get investment from Space Capital.
Love it. Okay. So very practical mindset. I like that, and really focused on the commercial need. I'd like to take that now and talk about your company and the market that you are operating in. So first off, ag tech is relatively new, at least from a venture capital perspective. The last few 3 to 5 years maybe is where we've seen a lot of the investment coming in. But then prior to the show, we were having a little chat and we were talking about the cockpit of a cotton harvester, a tractor that harvests cotton, and how it's like the inside of a space shuttle and how it's so advanced. And so can we start off by, what is ag tech exactly? What are the macro factors driving ag tech adoption?
Yeah, that's a great question. So when people think of ag tech, they think of new age startups that are all focused around, either data capture or analytics. But yeah, let's actually step back and have a look at what technologies were there in agriculture before this new age of startups came in. And you look at tractors and they're autonomous. And what that means is not like autonomous cars where you really need to take a lot of caution to not hit anyone and to reverse park and to decide when you're trying to get across the intersection first, whether you're trying to let someone go first.
There's a lot more traffic on the road.
Exactly. There's no traffic out there in the field. Well, you would hope that there isn't much. And that means that tractors had a free rein from the start. And for, good 20-odd years, they've been autonomous, meaning that you could press a button and it would cover your field in the right pattern and put the fertilizer or seed in the right place by itself. You don't need to be driving that tractor physically. That's one of the technologies that's extremely important, and probably later on in the podcast we'll touch on that, why this auto-steer, that's how they call it, the ability for the tractors to drive autonomously, as well as precision localization, where the tractor is at any given point in time, is so important. There are also other technologies like IoT, obviously, and the connectivity piece is very important for agriculture. If you have sensors, that measure your soil moisture, that measure your flow rate in your tanks, that, even cows' ears tags are connected, Those IoT technologies, they're only possible if you have good connectivity. And they existed before this new age ag-tech startups. There are quite a few other pieces that play into this mix, but those are the important parts. When you want to do ag tech, you want to have machinery, you want to have some sort of sensing. And I keep reminding people that satellites have been driving those tractors. Yeah. It's not the tractor itself, it's the satellite that sees that tractor, tells it where to go, and tells it where it is.
I bet there's more than a couple of audience members that did not see that coming. Tractors are driving our autonomous future. So the macro factors and what's driving this adoption of ag tech, it's population growth, it's the cost of the environment, as you mentioned.
Right.
Declining sensor costs, obviously.
Improving connectivity.
Yeah, what is it? What's really driving this from a macro perspective?
All of them. The fact that we're starting to invest in the governments are starting to invest more in research and development of innovation that will be underpinning higher productivity at a better cost. Meaning that you would use less fertilizer with the same amount of arable land and you would get higher yields, ideally. And in reality, it's not like magic. It's just that we have quite a bit of, lag of adoption just because there are inefficiencies there. And macro factors, of course, there's connectivity that's improving. Of course, there's research and science that's advancing. Of course, there's, this gloomy idea of this many billion people by 2050, and that number always fluctuates depending on whoever quotes it. So I'm not even putting the number on that. But we understand that we need to grow more with less. That's the bottom line. And the technology is now at the point where we can actually start harnessing it. And still, not all the farms are connected, but you can go to Bloomington, Illinois, and not have reception in that town, for example, or in any other place. So it's not just farms versus, it's not an urban-rural divide. It's just a connectivity, period.
Got it.
We need it everywhere.
Got it. And so population growth has come up a few times. A partner at First Round Capital has been quoted as saying they've deployed a lot of capital into this ag tech space. And he says, in agriculture, everyone sees that maybe not right now, but say in 15 years, water will be expensive, healthy soil will be scarce. And so why wait to work on that problem until it's a crisis? And so is that also true? And how serious is the water issue?
Absolutely. You're asking someone who's lived in Australia the last, 4 or 5 years. And water is a real issue. We have drought. It's the third year of drought, if I'm not mistaken, or at least the second. And we do have very mature water market because of that in Australia, that you can basically trade your water rights separately from your property rights. And here you have, in the U.S., you have quite a few aquifers, for example, in Nebraska, they're not thinking yet about where the water is coming from because it's just coming from the ground. Or in other places where you have abundance of it, in some other places like Kansas, people are actually looking for an edge in ag tech because they're seeing that water is either too much or too little. There's never quite the right balance. And it's a very important issue to be drawing the public's attention to because the water piece basically is a scarcity piece, whilst you also mentioned the soil and the deterioration of soil. And what that means is that when you are not treating the soil sustainably over time, meaning that you're actually improving its health, because it takes years to fix it. You can't just go 1 year and decide I'll put all my phosphorus, zinc, whatever, potassium in there, and it's all going to be great. It's 4 to 5 years in crop rotations and different practices that you need to adopt, and you need to actually incentivize someone to adopt so that the market doesn't, crash their bottom lines, that they can invest in the health of the soil long term.
So this is definitely coming. It's affecting some geographies earlier than others, and we're starting to see the market solutions and market dynamics that are coming to help manage the scarcity. I'm curious, so going back to ag tech more generally and connected farms, precision agriculture, where is it finding the most traction? Are there certain geographies like Australia, like you just mentioned, is one of the reasons why you're there? Are some of these geographies adopting it quicker than others? And what is the technology that's really leading the way here?
I think the adoption is driven by the urgency of the problem that people are seeing. And if you talk to people in California about water, they understand the issue. If you talk to them about nitrogen in the water, they understand the issue because that's been brought to them. There are measurements that are being made in the water and the parts nitrogen in the water that need to be reported. And now they are tasked with reporting on that. It means that it's brought to the forefront of their awareness. So what does that mean? That if an ag tech startup or an ag tech technology company would talk to that farmer or to that agronomist, they would say, yes, we understand we have a problem. We need to adopt the solution to this problem. Whilst in many cases, if they don't know they have a problem, you cannot pitch a solution to them. And so you see how drip irrigation companies come out of Israel because all of the water is recycled in cities like Tel Aviv. In Australia, there's a huge water issue. Therefore, drip irrigation or different systems for automation of irrigation are really important. Soil fertility and those things like nitrogen, it's dependent on whether people see a response and they have the water to actually be able to fertilize their soil. So when you're looking at the ag tech market, the way to understand where you're going to actually get traction is to understand whether people have the problem. And it's a startup manual type question, like what's the first thing on your mind when you wake up, and you keep asking them that. And if you're not in top 3, you're not relevant to them.
Right.
You should be talking to them.
Right. So interesting. Okay, so according to PitchBook, there's been nearly $8 billion in venture funding flowing into ag tech since 2015. And 2017 was a record year for farm-focused startups. There's also a lot of smart institutional money going into this sector, not just early stage angel crowdfunding. Like this is smart money and substantial money. And it's going to all kinds of companies doing things like farm networks, sensors and analytics, robotics and drones, farm management software, IoT sensors, and more. But I think that's kind of the general landscape. So lots of technologies, all sort of tackling different bits of the farm ecosystem. Who is Fluorosat, and where do you sit in that tech stack? And why there, and why is that the right place, the right point in the value chain to leverage and create value?
I'm really excited to tell you about our vision because I was just pitching it to the arguably America's best cotton researchers yesterday with one of our collaborators from Australia, and they absolutely loved it. And they said that they haven't seen it before, and they haven't seen it coming, haven't seen that someone actually embraced their needs. And so what Fluorosat's vision is that we actually are building the analytics engine. That means that we are collecting all of the different data sources. We are connecting to farm management systems, to IoT devices, to tractors, to all different range of satellites, to collect that information, because all of that is what's coming currently at a farm professional, at an agronomist, at a farmer and farm manager. And as a human, how much information can we retain and how much information can we utilize to creatively decision make?
Exactly.
Right?
You don't want to have 5 different access points to be able to
9
manage
at
your
least.
farm. Okay.
5. It's very humane of you. And so yes, one of the major problems is that I have 9 tabs, and I do not know whether the satellite image of my farm that has received this much rain and this has been the planting parameter actually is telling me that's good performance or bad performance of my field, because those factors that I just named in one sentence, there are 5 different tabs, and they need to live together. And this is what Fluorosense is doing for them. Fluorosense is our product. This is the name of our engine. And we're all about partnerships and about bringing the research and the science out of labs into the fields. So how it works is that imagine we have this infrastructure piece which collects all the different data from different sources. It homogenizes it, so we can ingest different yield maps, we can ingest different weather sources, we can ingest different farm management software inputs where they tell us how the farmer has managed their farm. And then obviously you have the derivative analytics piece, which is looking at, okay, what is the information telling us across the board? How can we run a crop model to see whether this crop is ahead or behind where it needs to be in development, and whether there is potential to improve its current performance and to improve yields? And it's all very situational awareness based, just like defense, You need to be looking at where you've come from, where you are, and where you're going. And Fluorosense as an engine basically takes a farm, takes a field, automatically monitors it using satellite imagery, airplane, drone, whatever you have handy or want to plug in. It looks at how the crop is growing, gives you alerts on when things are going wrong or there's something that's unidentifiable or something that's happening that can be deteriorating your yields down the track. And it can recommend ultimately the precision fixes. It can give your tractor the map to apply nitrogen. It can give your farmhand the anomaly area to go and scout. And ultimately it can learn because it's a closed loop system where you have applied that nitrogen. We have seen the effects of it in the chlorophyll levels of the plant by combining satellite imaging with crop modeling. And we tell you, hey, well, this really went great. Therefore, this soil is really fertile. You should look at it next time you're planting. Maybe you can get more out of it. Or when that farmhand goes and scouts that problem and tells us disease, we then understand that there's more of those spots around the farm and we can find them too. So that's where we're going with that closed loop system of data collection, act, measure, correct, act, measure, correct.
Yeah. And as we've been talking with you and learning more about this before we invested, the term data fusion came up quite a bit. And this is an area of expertise for you. So you really kind of sit in the center of all of these sensors, bringing in all this data together and making it really easy for the agronomist?
Yeah, for the agronomist, for the scientist on the farm, for those who are tasked with making decisions. And importantly, we sit in the center to help decision make, but how do we do it? We are using the models that are local models. So for Australia, it will be Australian models. For the US, it will be the US models. You can also calibrate it to the field and farm level. And when I say models, I'm talking about, the recipe type book. If you connect this soil to this hybrid of corn with this weather and you raise it, giving it this much nitrogen, it should have this yield potential. But then you start fiddling with all those parameters. Oh, Chad, your soil is actually like this, not like that. Or your weather, it's not like this, it's like that. And you assemble those parameters and you watch the crop grow and see if you had a good guess or if your guess needs to be improved. And because we're bringing that science that's developed by government, that's developed by universities, that's developed by farming corporations themselves, they can now actually monetize their data. It's not all the data that's coming at them that's just useless. So, they're not learning from it right now. Whilst if you plug the model at the back of it and you have a guess and you have a correction, then over time, your model improves and it's yours. And this is where it's really the key for fluorescence. We're not in the commoditized data capture space. We're not the smart cookie in the room that knows all models for all kinds of crops and all geographies. But we are the tenacious connector and the thinker to bring those together and enable the universities to get their science out of the lab and get to the farmers.
And by bringing all that data together, it all becomes more valuable, right?
Exactly.
And then that's how you stay ahead, and that's how your data and your information and your intelligence keeps getting smarter.
And you can truly stay ahead because you're involving everyone in the ecosystem and you're evolving together.
Yeah.
Instead of trying to keep it all, vertically integrated piece, and you will be responsible for sensors as well as for data collection as well as for ground truthing. We basically crowdsourced the ground truthing of our data, right? Because they're vested in the accuracy. They want to get their farm model better. I see the future of farming being like, the Tesla will have a dashboard with the battery connection to your home, and it'll tell you this is the performance of your home energy-wise. Well, think of a farmer. They'll have a dashboard when they will actually train their farm model. It's like, this is how we're performing on this crop and this season. That's where we're going, I think.
And then so who are your customers? You're not selling to the farmers directly. You're not running around and trying to talk to every one of the farmers out there. So how does your business model work?
Correct. So we're selling to agronomists. And agronomists are the scientists on the farm or the scientists up the value chain, basically, who the farmers trust to make decisions for them. Because those are the people that see a lot of data and they do a lot of experiments with that data. They have a lot of farmers that they serve. Think of them as a crop doctor. Everybody wants to have the crop doctor that they trust, but you don't necessarily want to have one in your family with you all the time. So in different size of families, you can decide whether your farm is big enough to actually have a own crop doctor or you need to go to a specialist that's just consulting as an independent. That's literally how it works. And the business model is that we are empowering those people with the data that is valuable at the decision-making point to truly move the needle in terms of the bottom line for their grower. And it comes in terms of efficiencies. We pre-analyze a lot of data for them so they can actually return back to their families and not click on satellite imagery day and night, because that's just not a viable option. As well as if they are trying to make a recommendation, we will give them the scientifically valid recommendation tailored to their farm.
Yeah. So to be an effective agronomist or farmer, you don't also need to be a satellite expert.
Yeah, not anymore.
Yeah.
I used to do that.
Yeah, and so that's interesting. So Earth observation satellites have been a source of information, really critical information for large-scale farms for decades, right? It's been around for a long time. How important is satellite data to precision farming?
We feel like it's a ubiquitous component of it right now. Of course, we can't remove clouds, and we want clouds, we want it to rain. But at the same time, we want the imagery so that we can see what's happening. And it's absolutely the critical component. And fluorescence makes it even more usable, because before people used to look at pictures. I'm a person driven by, problems that need solving, and I was frustrated by that. It's like, how do you know if your crop is doing better or worse? It's not a visual color coding game that you're playing here. What is the number? Can you give me the performance metric? You as a venture capitalist, you would know what's the growth, what's the compound growth, what's happening with that crop. And so in fluorescence, we turned it into numbers. And we can tell them, hey, well, this is how your crop is performing across the different parameters. And this is where satellite imagery becomes valuable, because then you can decide which field to harvest first, which fields are going, not as well as others. And you really start action in it. It's not just a lot of imagery coming at you and you're trying to figure out what's actually telling you. We have now tools to translate it into something you can understand and ask questions of.
Wonderful. And so as space investors, we've seen a number of companies trying to do what you're doing. And one thing that really stood out to us about you was your focus on building data partnerships that we talked about and integrations rather than trying to build and launch your own satellites or drones. Can you tell us a little bit about that strategy and why you decided to focus on the fluorescence approach versus, trying to address some of these other hardware, robotics, data supply side of things?
Yeah. Well, it comes down to whether you as a founder or as a business builder, you believe that vertical integration can actually get you to where you need to be. We believe that in agriculture, we're trying to think as an agronomist. We're the baby AI agronomist that they're trying to teach. So how does a real agronomist think? Well, they think I have all these data sources I need to combine together, and I do not care where they're coming from, because it's not a differentiated game of capturing data. It's very commoditized now. And in fact, I'm grateful to those startups that came before us and had to invest in imaging and had to invest in IoT and had to invest in tractor technology and in water control. Because currently, we're in a space where we can say, okay, we have all these toys in the sandbox. How do we actually let people play with them efficiently and connect them together?
Okay. And you've been very strategic in the investors that you've decided to work with. Can you tell us about what each of these bring to the table?
Oh, I'm just so excited to have the consortium we brought together, to have you guys on board, to have M12 on board, to have Costanoa Ventures, Grain Innovate Fund out of Australia, and have our existing investors reinvest. And I just had a call with the founder yesterday about one of our investors. And he said, well, how did you get them to invest? And I said, well, that's a wrong question you're asking. Why do you want them to invest? Why are they going to bring value? Because there is so much money out there, but ultimately it's you and I in the boardroom, right? And we're making decisions about where the company is going. And are you the right person to sit with me in the boardroom and really grasp the concept of what I'm trying to build? And with your expertise, bring it when I need it, when I need to hire that person, when I need to go make that go-to-market decision, when I need to decide to move my engineering team or not, when I need to decide how to get in front of this big customer and what's the backend that I need. And if you imagine that process, which founders obviously go through quite often, of decision-making together with their board, with the consortium of their investors, you really want the right people around you. Because, there's a phrase that they have vested interest. Well, that's literally it. And you want the best people to have vested interest in your success.
Absolutely. Okay, so looking to the future of farming, siloed data will be a thing of the past. Connected farms will share data on inputs, and decision-making will go down to the plant level, is how we've kind of talked about it and where we think this is going. So you've just raised 4.5 million Australian dollars. What would this latest funding round allow you to do? What's your grand vision for the company? How does Florasat become an app platform like Salesforce?
Yeah, I definitely see our stickers on all the different tractors and powered by Fluorescence logos on them because we truly want to connect satellites to tractors in that data flow with strategic intervention of the human being. So that's the grand vision. And the current round that we've raised, we really want to focus on Americas, on both North and South America. We have pretty good traction here in the North America, in the States specifically. Canada, in its agricultural sense, is similar to Australia in terms of the crops they grow. And so that's the next expansion market for us, as well as Latin America. We have interested users across Latin America that we need to capture, start supporting, and understand who are the right partners in that market to bring the science that's local. Of course, we've hosted delegations from Brazil and Argentina in our Sydney office because everybody knows how great Australian cotton is and how high quality it is. And so we get a lot of interest when we receive those delegations. But now it's our time to put people on the ground and to actually start those conversations. How are we going to improve the lives of the farmers in their regions, in their neighborhoods?
Great. On our show, we like to say that there's never been a better time to get involved in space investing. Can you give us your personal perspective on that and which areas are the most exciting for you?
Oh, I'm really excited that you've decided to open up to ag tech because this is the sustainability of the world. This is how we need to support it. And space is so critical. Although people embrace it, understand it, or ignore it, it's still all based on navigation and imaging that comes from satellites. There is the space where we need to be thinking of the vertical analytics. And I would want other entrepreneurs like myself to go and think about what are the other industries where you can actually do something with space data and make a difference. It's not just about agriculture or mining or utilities. It's actually about what is the tangible difference that you would feel if I could map all of the parking lots in New York. And when you're going to work, I would tell you, Chad, the one that you spotted or reserved is now taken, for example. Go to another one. And that will be satellite technology. And not making this up completely because there is a startup that does that. But think of how we can actually improve the world when we have this pervasive sensing technology that just tells us the right information at the right time. It's like that GPS on your phone. You're not thinking anymore. You're just asking Google Maps where you need to go. What about making more of hard life decisions being like that? What about eliminating the frustration, both in the urban and in the rural worlds?
We absolutely agree with you. Earth observation is going down the path to be as ubiquitous as GPS in our daily lives.
Exactly. And we just need to know a little bit more about it so that the new generation of STEM students will become STEM entrepreneurs and they fix those problems.
Anastasia, it was great talking to you. Thank you very much for your time today.
Thank you for having me, Chad. Thank you.
Thanks for tuning into the Space Angels podcast. If you enjoyed this episode, please leave us a review on Apple Podcasts or wherever you get your podcasts, and subscribe to make sure you never miss an episode. If you're interested in learning more about investing in space startups, I invite you to visit our website, spaceangels.com, where you can learn all about Space Angels membership and how you can get involved in this exciting new innovation economy.